Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do here every Wednesday, which is just really pour into you and give you the confidence and competence that you need to pass that certification exam. So we are here to give you the confidence that you need because let's be honest, that confidence, when you are lacking it, really affects your ability to solve these problems correctly because you start second guessing yourself. And if you don't have the math skills that you need to solve those problems, then your confidence is going to be low anyways, but you also just don't have the foundation. And so we're here to help you with both. So we are here every Wednesday solving problems to help you. We do K-12. And so we are doing problems across all grade levels. And so if you have something that you want to see, just let me know. I always have a next week section. And so in the comment box, as we're working together, just let me know what you want to see me solve in the upcoming weeks. You will see problems tonight that are specifically requested by other people, whether they are specific problems or skills. That is, that's why we're here. So let's go ahead and get started with just some introductions. It makes it feel a little bit less like a computer screen, a little bit more like we're sitting in my living room eating ice cream, drinking whatever you want to drink, water, lemonade, whatever, something else. So let me know in the comment box where you're from. What test are you prepping for? And do you like cold weather or not? Do you like the cold weather? What kind of temperature is like your ideal temperature? My name is Amy Sink. Like I said, I am from Central Florida. I was born and raised here, grew up here. Florida is not my ideal location. I absolutely love the cold weather. We have had a massive cold front come through Florida to the point where they're like talking about potential snow in North Florida, which I would love. I love the snow. I love the cold weather, but I don't love the snow so much that I want to shovel it every day. But I do love like the 30s and the 40s. I don't know. I just love it. All my Floridian friends are like, get me out of the cold. And I'm like, give me more cold. So it is my absolute favorite. Let me know where you're from. What test are you prepping for? And do you enjoy the cold weather or do you not enjoy the cold weather? So yeah, like I said, let me know in the comment box what you want to see me go over in the upcoming weeks. And let's go ahead and get started with the first problem. Ooh, excuse me. Problem 1. Use the figures below to answer the question that follows. So we see this figure right here. And we are going to solve that problem. The sequence of squares shown above can be combined to form the following figure below. An 8th grade teacher is using the sequence of squares to shown to introduce inductive reasoning. If the sequence continues by adding the next odd number of squares at each step, which of the following formulas is the best conjecture that can be made with the sequences shown? This is a really interesting problem. And to be honest with you, the first time I saw it, I was like, whoa, those answer choices are kind of a little bit crazy, and I'm not entirely sure where to start. However, as you start to really dig into the problem, you start to realize that it really isn't that complicated. So let's go ahead and explore this. So our first sequence has 1 square. We're gonna put how many squares are in each slot. So this is slot number 1, 2, 3, 4, 5. And in the first slot, there's 1 square. In the second slot, there's 3 squares. In the third slot, there's 5 squares. In the fourth slot, there's 7 squares. And really all we're doing is adding a square on top and to the side each time, right? And so this whole sentence, I'm going to be really honest with you. This whole sentence is there to just kind of throw you off. It's a whole lot of words that really don't apply. Now, don't get me wrong. Sometimes the words are helpful and we need them. But in this case, that's a whole lot of words for not a lot of give back, right? However, what they're asking is, let's go straight to the question. The question is, which of the following formulas is the best conjecture that can be made with the sequences shown? Which of the following formulas works, right? 1 plus 2 plus 3 plus n equals this whole big thing. 1 plus 3 plus 5 plus blank plus this equals blank. 1 times 1 factorial, 2 times 2 factorial, 3 times 3 factorial plus this equals this. Or 1 squared plus 2 squared plus 3 squared plus this equals this. So what am I trying to equal? I'm trying to equal the number of squares each time. And so if I look at this, I'm not adding the actual spot that they are sitting in. I'm going to add the actual number of blocks. So it's not going to be A, because I'm not going to add spot number 1 plus spot number 2 plus spot number 3, because if I'm using a formula, I'm trying to figure out how many blocks I have. I'm not trying to figure out what spot they're sitting in. And if I am, I'm going to be solving for a different variable. However, if I look at B, 1 plus 3 plus 5, 1 plus 3 plus 5, hey, we're on the right track. 1 squared plus 2 squared plus 3 squared, that's not going to help me. So that's not it. And C, 1 times 1 factorial, 2 times 2 factorial, 3 times 3 factorial, that really doesn't seem like it's it either. But in order for me to confirm, because this isn't really a formula that I just keep memorized in my head, I'm going to plug in numbers to see if it works. So spot number 5 is going to have how many blocks? 9, right? Spot number 5 is going to have 9 blocks. So if I do 1 plus 3 plus 5 plus 7, because I'm going to go all the way to this spot, plus 2 times n, where n is the spot number that we're sitting in. So 5 minus 1 equals 5 squared. So 1 plus 3 plus 5 plus 7, 1 plus 3 plus 5 plus 7. Does this equal 9? Yes, 10 minus 1 is 9. And does all of that equal 25? If I use my calculator, let's go ahead and find out. 1 plus 3 plus 5 plus 7 plus 9, 25. So between you and me, when I first looked at this problem, my first thought was, oh gosh, I don't know how to solve that problem, even as your math specialist, even as your math expert. However, the more I dug into it, the more I realized I can just use process of elimination and use what I already know about sequences to figure it out, right? So some of this is not about content knowledge. It's about using your baseline knowledge to really solve the more complex problems. Let's go ahead and look at problem number 2. The product of the first 3 terms of a geometric sequence is 216. And the sum of the first 3 terms is 21. Find a possible common ratio and the first term of the sequence. Find a possible common ratio and the first term of the sequence. So this is a fun one because we can totally do this algebraically. But and that is usually, I am a very algebraic minded person. Like I'm not a geometry person. I'm an algebraic minded person. So I typically like to look at things through an algebraic lens. However, the answer choices are there to help you. Yes, sometimes we don't have answer choices, but anytime I have answer choices, I'm going to use the answer choices to help me if I can. So I am going to use these answer choices to help me. What did they tell me? They told me the first 3 terms of a geometric sequence. What is a geometric sequence? It's a sequence with a common ratio, whereas an arithmetic sequence just for kicks and giggles, has a common difference. And so we have a common ratio. A common difference means we're adding and subtracting. A common ratio means we're multiplying or dividing. And so if the first 3 terms of a geometric, if the product, which means answer up, let's use a different color. So product is the answer to a multiplication problem. And sum is the answer to an addition problem. The product of the first 3 terms of a geometric sequence is 216. Well, look at your answer choices, y'all. They give you the first term and they give you the ratio. So I can just sit and plunk, plunk, plunk and see if it equals 216, plunk, plunk, plunk and see if it equals 21, rather than sitting here and trying to come up with, okay, A, comma B, okay, A, type, what kind of formula am I going to use? Don't get stuck on that. Use your answer choices. So A, if the first term is 4, then I need a second and a third term because we need the product of the first 3 terms and we need the sum of the first 3 terms, right? So 4 with a common ratio of 2/3. 4 times 2/3, and then that thing times 2/3. Use my calculator. Four times 2/3 is 2.67. And 1.77. That added together is not going to give me 21. I don't even need to multiply it to know that it's not going to equal 216. 4 plus 2 plus 1 is never going to give me 21, so it's not A. B, the first term is 9. with a common ratio of 3 halves. So 9 comma blank, 9 times 3 halves, and then that times 3 halves. So 9 times 3 halves, 13.5 times 3 halves, 20.25. That's too much. The sum of the first 3 terms, term 1, term 2, term 3, that's more than 21. 20 plus 9 is 29. So that's not going to be the right answer either. C. 4 with a common ratio of 3 halves. So 4 comma blank, 4 times 3 halves times 3 halves. 4 comma 6 comma 9. 9 times 6 times 4 equals 216. 9 plus 6 plus 4 equals 19. That's interesting because I'm pretty sure that's the right answer, but let's keep going. Yeah, that is supposed to be the right answer. So obviously this was supposed to be a 19, not a 21. My bad. But that is how you would solve that entire problem. Okay? Questions? Comments? Concerns? Let's move on to problem number 3. Students were measuring how much water can fill a large jug and how long it would take for the water to fill the jug. Which of the following would be the best choice to represent this data? All right, so students are measuring how much water can fill a jug. So here's my water. And here's my jug. And we're just going to make it a bucket, all right? And we're measuring how much can go in and how long it's going to take to fill the jug. A histogram is going to look something like this. And so that's not really going to tell me how much and how long. A pie chart is more of a comparison. Like I'm looking at how many people or what percentage of people voted for something or chose something. That's not going to be the right answer either. But when I think about a linear graph, and we're looking at a constant stream of water into this jug, and we're looking at how much water, amount of water over how much time, because the amount of water depends on how long I've been filling it up, right? The time is not going to depend on the amount. The amount is going to depend on the time. Then we are definitely looking at a linear graph. Box and whisker plot typically refers to more isolated, like singular data points. And so that's not going to be the right answer either. Hello, you're watching me from another account, but I don't know who you are. Let me know who you are and I'll say hi. I mean, hello, I've already said hello, but let me know who you are. And my foot just totally fell asleep, y'all. Ooh, I can't even feel it. It's that asleep. I was sitting crisscross applesauce in my chair. Probably not the best idea. All right. Oh, hi. Good to see you. All right. Let's go ahead and move on to problem number 4. If each value in a data set was increased by the same amount, which of the following statements is true? If each value in a data set was increased by the same amount, which of the following statements is true? The mean and range will remain the same. The mean will increase and the range will remain the same. The mean will remain the same and the range will increase. Or both the mean and the range will increase. All right, this is an interesting problem because it's certainly not something that I have like committed to memory necessarily. It's certainly not something I've committed to memory or anything. However, what I do know is I can create my own little set of data and I can test it out. So what I don't want you to be afraid of is I don't want you to be afraid to create your own problem within a problem. You'll notice if you spend enough time with me that I will often create a problem within a problem if what they've given me is confusing to me. So what I'm going to do is I am going to create my own set of data because I don't know if I don't memorize this kind of stuff, if the mean or the range are going to remain the same or they're going to increase or they're going to do it. I don't know, but I don't need to memorize that. I don't like to put stuff in my memory that's like stuff that I can do on my own. So let's create our own set of data so that we can test this data. Let's just say it's people's favorite numbers, like something super easy. And we're going to do 4, 7, 7, 9, and 10. There's my data. Done. It doesn't have to be huge. You want it to be more than like 2 data points. So I don't know why, but I like to do 5 data points because it's just easy. And I like to do a mixture of even and odd numbers just to make sure that I'm not skewing my data at all. And I don't need you to find the mean, median, mode, and range. You only have to find the mean and the range because those are the only 2 things that are being asked about in this question. So remember, your mean is your average because it's very mean. It makes you do a lot of work. And your range is the difference between the highest and lowest data point. So I am going to find my mean and my range for this data set, and then I'm going to find my mean and my range for my updated data set. So my mean is my average, so I'm going to add them all up and then divide by the number of data points I have, which I only have 5 data points. And my range is just the difference between the highest and the lowest, which is 6. So let me go ahead and do that in my calculator. 4 plus 7 plus 7 plus 9 plus 10 divided by 5, 7.4. Now, what did the question ask? The question said, if each value is increased by the same amount. Each value is increased by the same amount. So now data set 2, I'm going to increase them all by 3. 4 plus 3 is 7. 7 plus 3 is 10. 9 plus 3 is 11. 10 plus 3 is, no, 9 plus 3 is not 11. That would change it. 10 plus 3 is 13. So my range is 13 minus 7, which is still 6. Range is the easiest to find between mean and range, right? Like range is easier than mean to find. So now what am I going to do? Now I'm going to look at my answer choices. I'm not going to go and find my mean. I'm going to look at my answer choices and figure out, okay, which of them say that the range stays the same? Because if I don't have a whole lot of time, I can at least, range does not increase, range does not increase. If I'm running out of time, I can at least pick one of these 2 options from my 50-50 shot, right? Is my mean going to remain the same? Well, let's write it out. Mean is going to be 7 plus 10 plus 10 plus, and it just disconnected. Y'all, I'm going to be honest with you. I was actually getting so excited because my iPad was staying connected and then it disconnected. So let's go ahead and reconnect it. This happens every once in a while, and I just don't understand why. Just doesn't make sense to me. But as we're sitting here, while we're waiting, if you are watching this, let me know in the comment box, what do you want to see in the upcoming weeks? While we're waiting for the computer and the iPad to play well together, what kinds of things do you want to see in the upcoming weeks? Are there specific topics? Are there specific questions? What do you want to see in the upcoming weeks? And that will help me curate the upcoming sessions to meet the needs of all of you who are here. What do you want to see in the upcoming weeks? All right, here we go. We're rocking and we're rolling. We're rocking and we're rolling. We're rocking, we're rocking, we're rocking and we're rolling. All right, so what do you notice? 7 plus 10 plus 10 plus 12 plus 13 still divided by 5 because I still only have 5 data pieces in this data set. So naturally, what's going to happen? Naturally, the mean is going to increase because my values in my data set are increasing, but I still have the same number of data pieces. And if you could not see that right away, you don't need to worry about that. It's okay. Let's go ahead and look at it in a calculator just to confirm, because sometimes our brains just like to confirm. 7 plus 10 plus 10 plus 12 plus 13 equals 52 divided by 5 is 10.4. Questions? All right. You would like to see more geometry and more binomial probability. Are you talking about like binomial expansion? And if you're not, that's fine. Just let me know. All right, let's go ahead and move on to the next problem. A contest was hosted with 283 students. If a student placed 34th in the contest, what was their percentile rank? Whoops, I dropped my pencil. If a student placed 34th in the contest, what was their percentile rank, assuming that no other student scored the same score as that student, and that first place is the best score? 12, 34, 88, 143, or 249? All right, right out the gate, right off the bat, we notice that there are 2 answer choices we can immediately eliminate. We can immediately eliminate D and E. Why? Because the question is asking, what was their percentile rank? What was their percentile rank? Which means we are looking for a number between 1 or 0 and 100. Because in a percentage, 1 whole is 100. And so we're not going to have, now, can you have percents that are bigger than 100 or smaller than 0? You can, but in this case, a percentile ranking is going to be from 0 to 100. We're not going to be more than 100. So a contest was hosted with 283 students. The student placed 34th in the contest. So the first thing I need to do is figure out what decimal 34 out of 283 is. So if I do 34 out of 283, then that gives me the decimal value of this fraction of where 34 is in the scope of 283. So let's go ahead and use our handy dandy calculator. And that equals 0.1201413, right? And so what does that mean? That means that 34 out of 283 is 12% of 283. But what that really tells us is if I flip it, because percentile ranking says how many students scored under you or how many students scored below you. If you're 34th out of 283, you scored higher than a lot of students, right? Well, what percent of students scored higher or lower? I need to flip this percent because you are in the top 12%. However, if I subtract 1 whole minus 0.12, that gives me 88%. So I scored higher than 88% of the students. Now, that makes sense because 34 is like really good out of 283. Like if you scored 34th out of 283, you did really well. So your percentile rank is probably going to be pretty high comparatively. So really, the answer choices here were not the best because you probably could have conjectured that it was going to be 88 because it was greater than 50th percent, right? All right, let's go ahead and move on to the next problem. Two cars are driving in opposite directions toward each other. They are each driving at a constant 45 miles per hour. If they are currently 10 miles apart from each other, about how long will it take for the two cars to meet? Okay, this is an interesting one. And someone specifically, this should actually be starred because someone specifically asked for like speed, time, velocity. So two cars are driving in opposite directions. I'm going to be real honest with you. I have a really hard time visualizing this kind of stuff. And so I have to just draw it out. So I'm going to draw two cars. Two cars are driving in opposite directions toward each other. So here's a car. It's called a hat car. And here's a car. And this car is going this way. And this car is going this way. They're going in opposite directions toward each other. If they were going in opposite directions away from each other, then this guy would be going this way and this guy would be going this way. Or lady. I don't know why I said guy. But they are going in opposite directions toward each other. They are driving at a constant 45 miles per hour. That word constant is important because it means that there's no increase or decrease in speed or stopping and going. So this one is going 45 miles per hour. And this one is going 45 miles per hour. They are currently 10 miles apart. How long will it take them to meet? How long, if they are going at the same speed in opposite directions, how long will it take for them to meet? Well, this one is a little bit more straightforward than some, because if they're going at the same speed towards each other, then they're going to hit the middle point when they meet. However, if this car was going at 30 miles an hour and this car was going at 15 miles an hour or 10 miles an hour or whatever, they're going to meet closer to that 10 mile an hour car because that one's not going as fast. But because they're going at the same speed and they're 10 miles apart, they're going to meet at the 5 mile marker because they're going at the same speed. Does that make sense? So really what I can do is I can use my speed equals distance over time formula, and that's a good formula for most of us to know. Speed equals distance over time. And I know my speed and I know my distance, but I don't know my time. I know my speed, I know my distance, but I don't know my time. And the reason I know I'm looking for time is the question says, how long? How long? That tells me I'm looking for time. Speed equals distance over time. Well, my speed is 45 miles an hour. What is my distance? My distance is not 10. I'm not looking to see how long it takes this car to travel 10 miles. I'm looking to see how long it takes for them to meet. The distance is going to be 5 because they're going to meet at that middle point. So 5 over time. How do I get time by itself? Multiply both sides by time over 1, and that cancels. So 45 time equals 5. Divide both sides by 45. Time equals 0.11111 hours. Because my speed is in miles per hour, my time is going to be represented in hours. How do I flip hours to minutes? Multiply it by 60. And when I do that, it equals 6.67, which is going to round to what? 7 minutes. Good job. It's not going to round down to 6 minutes because it's not, it says about how long, so we're going to round up. However, think about that. Like when you're solving problems, there are going to be problems where sometimes you're going to end up estimating down. So for instance, if this problem said, so many kids can go on so many buses, how many full buses are we taking? Well, that would be a terrible, terrible example. When would I round down? I can't think of an example off the top of my head. But I know you would round up, like if it was 6.1, okay, how many full buses are we taking? It would be 6. How many buses would I need? I would need 7 because I would need to put those extra kids on a bus. I don't know if that even made sense, but like you just have to realize in the context of the problem how you're going to round, if that makes sense. Now, some of you are like, how would I solve this if it was like 2 different speeds? Because they wouldn't be meeting in the same spot. Let's go ahead and do a problem like that. So I'm going to actually, this is where I go a little bit off the script, which is okay. But let's go ahead and erase some of this. Let's erase some of this. All right. Okay, what if car 1 is driving at 45 miles an hour and car 2 is driving at 20 miles an hour? How would you solve that? How would you solve that? So I'm still going to do speed equals distance over time. Still going to do speed equals distance over time. But I'm going to add my speeds together. 45 plus 20, which equals 65. And instead of trying to calculate what that distance is, my distance is just going to be the whole 10 divided by time. And that will tell me where they're going to meet. because I'm calculating their whole speed and distance together. So it'll tell me that meeting point. So I end up with 65t equals 10, divide both sides by 65. T equals 0.153 times 60, which is 9 minutes. So by adding them together, it gives you their combined speed at traveling that 10 miles. And so it gives you that meeting place for them. Does that make sense? All right, let's go ahead and move on to the next problem. Ooh, another speed and velocity problem. Two cars start at the same point and are driving in the same direction. Car A drives at a constant 35 miles per hour, and car B drives at a constant 50 miles per hour. How long will it take for the two cars to be 50 miles apart from one another? Two cars start at the same point and are driving in the same direction. Car A drives at a constant 35 miles per hour, and car B drives at a constant 50 miles per hour. How long will it take for the two cars to be 50 miles apart from one another? All right. So this time I have, I want two colorful cars. Car A is traveling at 35 miles per hour, and car B, gator colors, is traveling at a constant 50 miles per hour. How long will it take for the two cars to be 50 miles apart from one another? All right, so we can approach this two ways. We can approach this with the same speed equals distance over time. However, you're like, but they're traveling in the same direction. What is my speed? Is it the 35? Is it the 50? And that can get confusing. I know that I'm looking for my time because it says how long. Speed equals distance over time. And I know my distance is 50. But what is the speed? If that is something that confuses you, I want you to approach the problem a little differently. So if they're going at a constant speed, right? Then car A after 1 hour is at 35 miles. And then 35. And then 35. Each hour, that car is going 35, 35, 35. And each hour, this car is going 50, 50, 50, right? How many miles apart are they separating each hour? After the first hour, this car traveled 50 miles and this car traveled 35. How many miles apart are they after the first hour? 15. 50 minus 35. They are 15 miles apart right now. Well, each hour they are going to get 15 miles apart, right? Every hour is going to be 15 more miles. And I want to know how long it's going to take them to get to 50. So 15 plus 15 plus 15. So this is 30 plus 15. This is 45. So it's going to be longer than 3 hours. E is your right answer. I did all of that without using a formula. I just did it with visualization, right? Okay, let's look at speed equals distance over time and how to solve it using that method, okay? Let's look at how to solve it using speed equals distance over time. So, what is my speed? My speed is going to be the difference between the two of them, not them together, because they're not going in opposite directions and exponentially separating from each other. They're just incrementally separating from each other. And so my speed is going to be that 15 equals distance over time, and then you can solve it from there like we've solved the others. So multiply both sides by t. 15t equals 50. Divide both sides by 15. T equals 3.3. Now, if the cars were traveling in opposite directions and we wanted to know how long it was going to take them for them to be 200 miles apart, if they're traveling in opposite directions going like this, then instead of subtracting their distances, or subtracting their speeds, we would add their speeds together, because after 1 hour, they would be 85 miles apart. After 2 hours, they would be 170 miles apart. So you're going to add those speeds because they're traveling away from each other. So they're getting away from each other a lot quicker. Whereas in this case, they're kind of just tracking with each other. Does that make sense? All right, let's go ahead and move on to problem number 7. We're moving and grooving today, y'all. In a bag of red and green sweets, the ratio of red sweets to green sweets is 3:4. If the bag contains 320 green sweets, how many red sweets are there? If the bag contains 320 green sweets, how many red sweets are there? All right, this is a fun one. This is probability, and probability is just something that a lot of people just naturally struggle with. It's not something we use often or on a daily basis necessarily, unless you're like a statistician. And so it's something that we just, you're not doing you might be doing 2 + 2 or simple addition every day, but you're not using probability every day. So let's go ahead and look at this. And I'm going to use red and green to delineate on these problems. So the ratio of red to green is 3:4. The way you read it is literally the way it's represented. Red to green, 3:4. So I have red to green. If the bag contains 320 green sweets, how many red sweets are there? So when we look at this, if you notice how I set it up with red to green equaling red to green. It is important when you set up a proportion like this that each side is equivalent. So I'm setting up red to green, red to green. I'm not doing red to green, green to red. Or I'm not doing red to green and green to total. I'm doing red to green, red to green. Okay? Now, because I've set them up the same, I can cross multiply and solve, right? So I can do 3 times 320 equals 4 times x. So 3 times 320 is 960. Divide both sides by 4. X equals 240. So there are 240 red sweets. Now, what I caution you on is if this said something like the ratio of red sweets to green sweets is 3:4, the bag contains 960 total sweets, then you wouldn't do 3:4 equals x to 960, because then that would be red to green, red to total. And so you would have to figure out like the total on this. You would have to do a different process, and I can absolutely do something like that if that's something that you want to see, because then there's another step in setting that up, because you have to make sure that those two sides equal each other. All right, let's move on to problem number 8. John has 30 marbles. 18 of which are red and 12 of which are blue. Jane has 20 marbles, all of them either red or blue. If the ratio of the red marbles to the blue marbles is the same for both John and Jane, then John has how many more blue marbles than Jane? So this is going to turn into a multi-step problem because the question asks, how many more blue marbles does John have than Jane? Which is a subtraction problem. How many more just tells me I'm doing some subtraction. But I have to figure out how many blue marbles Jane even has. John has 12 blue marbles. So I know I'm going to need to do 12 minus something. But Jane has 20 marbles. All of them are red or blue. We don't know how many red, how many blue. I do know that there's going to be more red than blue because the ratio is the same for both John and Jane. But I don't know how many red or blue Jane has, but I do have the total. This right here is where I was talking about how we're going to have to set it up differently. So John has 30 marbles. 18 are red, 12 are blue. I'm going to set up a proportion where I have blue over total equals blue over total. I'm not going to do blue over red equals blue over red because I don't know how many blue or red Jane has, but I do know what the total she has is. So I'm going to do blue over total equals blue over total. I don't know what the blue is, but I know what her total is. Cross multiply. 12 times 20 is 240 equals 30x. Divide both sides by 30. X equals 8. That's how many blue marbles Jane has. But don't let that distract you from choosing that answer, because that is not the right answer. The question was, John has how many more blue marbles than Jane? 12 minus 8 equals 4. It's important for us to know what that question is so that we don't make a mistake in how we solve it, especially when we would have gotten the right answer, right? Like you did all of it correct and then you choose 8. That would hurt, right? But if we really read that question, sometimes I like to go back and read the question a second time just to make sure that I'm answering the question in its entirety, right? All right. Next week, what do you want to see? I am going to turn it back over to Dr. A. However, I'll be monitoring the comments throughout the week, so let me know what you want to see me go over in the upcoming weeks. I do have practice problems that some people have requested already, and so I will absolutely include those moving forward. I'll include some geometry. I'll include some binomial probability. Let me know. I look forward to seeing you next week, and I hope that you all have a great rest of your week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. but this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.